Okay, so remember when we have a question like this. Now the first one says that show that the decimal, we are given a decimal. Sorry, we are given a decimal 0.28, and then they want us to show that this number is a rational number. When we talk about rational number is any number that can be written in the form of a over b. So we can write, they want us to show that this can be written as a fraction. Okay, so first thing first that I need you to do you know what is these dots on top meaning? These two dots.
That the numbers are repeated.
Exactly, recurring numbers. So you'll definitely get that in your text. So now when it's recurring, to answer 1.1, we can just let x to be that recurring number, but it's going to be 0.28. I'm sorry, the 0.28 is the one that is recurring, so the next number will be 28, the next number will be 28, and so on. You understand that part?
Yes.
And this will be my equation 1. So now uh, what you're going to do, you're going to multiply. Now you check how many numbers are recurring, two of them. So if there are two of them, we know that 100 has two zeros. We need to multiply both sides by 100. We need to take the x, multiply that x by 100, and we need to take the 0.282828 multiplied by 100, which will give us 28.282828, and so on. So it will keep us giving the 282828. You understand?
Yes.
And this will be my equation 2. So now when I have it like this, we're going to take equation 2, we need to subtract equation 1. So we're going to say 100x minus x will give us 99x. Then we need to take the 28, we minus the 0.28. So these recurring numbers, the 2.282828, will be we're going to get rid of that 282828. So this will just be 28. Okay, I'm not sure if you're still with me on that part.
Yes, I am.
Okay, so now how can we solve for x? We can just divide both sides. We can take the 99x
By 99.
exactly. So we can just divide the both sides by 99, divide the other side by 99. Therefore, there we are. We have x to be 28 over 99. So we did show that this is a rational number because it can be written as what? It can be written as a fraction. So when they say show that a number is a rational number, just know that they are looking for you to write it as a fraction.
Okay.
Right. Are you happy with that?
Yes.
100%. Okay, so let's move to the next question. Okay, so the next question says determine without the use of a calculator between which two integers the number root 42 lie. You understand? So we have the number root 42 lie. So I'm going to give you the best plan that you can use to answer this question. Okay,
Yes.
do you know your perfect squares?
I think so.
Okay, 1 is a perfect square because 1 squared is equals to 1. Then we have 2 is a perfect square because 2 squared is 4. 3 squared is 9. So this tells me that 149 is a perfect square. And then 4 squared is 16. So 16 is a perfect square. 5 squared is 25. So 25 is a perfect square. 6 squared is what? Is 36. And then what about 7 squared? 49. So I'm going to stop here. Let me explain why now. My aim with this problem, I want to choose two perfect squares that the 42 is between. So look at this. We know that 42 is between these two numbers. You understand?
Yes.
So to answer this 1.2, you're going to take the root of 42. Ne? You say this root of 42, it must be less than, we say it must be less than the root of that 49. So it should be less than root of 49, and then it should be greater than root of 36. Tell me if you understand what I did. First thing first, you need to find the perfect square where your 42 lie between. Then from there, we know that the root of 49 is just that 7. If we square root 49 is 7, and then this will be root 42. We're just gonna leave it like that, and this will be greater than what? This will be greater than 6. So when you give it to them like that, then you can conclude and say that the root of 42 lies between 6 and 7. So even if you punch root 42 on your calculator, you'll still get that the answer is between. Yes. I'm listening.
Oh, like I remember doing the class.
Nice. So you just have to take what you see. This is easy. You just have to take whatever that they want us to show. It lies between two integers. So now we take that root 44. We do the perfect square. We do the perfect square. Then we need to check where is that lying. For example, let us work on one example for a quick practice. So if I ask you where is the root of 27 lying, we need to find the perfect square that are between 27. So it's going to be what? Look at this. 27 is between 25 and 36. So we're going to say this 27 must be less than the root of 36, greater than the root of 25. So the root of 27 will be between 6
and 5.
Exactly, and 5. Therefore you write and say root 27 lies between 5 and 6. Thank you very much. Let's move to the next question. Let's see what we have here. So we're going to factorize. They want us to factorize the following expression, and this is what we are given. We are given a squared, a to the power 3 minus a squared, and this is just 1 mark. So this one, to factorize this, we're just gonna just only take out the common factor, then we are done. But we need to take the highest common factor, which is a squared. Please pay attention. This is a squared. Where there's a squared, if we take it out, we're just gonna replace that a squared by 1. So I'm going to put a squared outside, and then inside a bracket I have a to the power 1, because remember, when we multiply the same base, we add the exponent. So we are left with what? With a to the power 1 minus 1. Then this is fully factorized. Are you happy with that?
Yes.
Okay, let's work on this 1.3.2. Look at this question. They want us to factorize y squared minus yx minus z squared minus zx. You know, first thing first, let's put this z squared and the y squared together. Let's group them. We can write this as y squared minus z squared, and then we can group the minus yx with minus zx, because can you see that we have a common factor of x? We can take out that common factor. But before we do that, this is just the difference of squares. You see, y squared minus z squared, we can just open two brackets. Since it's negative, the other part will be y plus z, the other part will be y minus z. So trust me, you see these two now, if you multiply out the bracket, they should give you that part. So when you have something like this and say this is a squared minus 2, or minus, let's say this is minus 4. So the minus 4, we can change this, just give me a second. We can change the minus 4 into what? The 4, we can write this as a squared minus 2 to the power 2. So when we factorize this, it will be a plus 2 into a minus 2. So this is exactly what we did on that one. I hope you understand that part, ne?
Yes. Wait, is that a set or two?
No, for this example, it's Z is 2, but for this example, it's Z.
Okay.
I was just showing you how to do if you have a number here. Ne?
Okay.
Make sure
And
that
where
you
does
write.
the X go?
I'm listening.
Where does the X by the Y minus YX, where does it go?
I'm listening, Asa. What are you saying?
You see the YX, the minus YX, where does the X go?
This one, the minus YX.
Yes.
No, I'm not done with that question. I was just
Uh,
showing you how to factorize the difference of squares if this is a number. We can also
okay.
factorize b squared minus 9. First thing first, we need to write the 9 to squared. So this will be b squared minus 3 squared. Then the other side will be b plus 3 and the other side will be b minus 3. You understand? I'm just trying to remind you how to factorize those type of questions, okay?
Yes.
Okay. I just hope you're going to do well tomorrow on your test. So now what I'm going to do, I'll just say, let's do this and say, okay. So now if we still do this, we still have the, look at this, we can take out x as a common factor, left minus x into y. What will this be? Since we have negative out, this will be y plus z. Right, so this is what we have. Now I have a common factor again. And what is that common factor?
Y plus Z.
Exactly, so we need to get the y plus z outside and we'll be left with y minus z, and then we still have minus x, and this is fully factorized. We can just leave it like this and say this is fully factorized. Okay,
Okay.
you happy with that one?
Yes.
Okay, now let's work on 1 point. I'm not sure where are we going to put that one, the 1.4.1. Okay, we don't have that.
You can erase it first. I wrote it down.
Oh, it's fine. Let us put this one here. Okay, so on 1.4.1, this is what we have. We are given y squared, this is minused by y minus 6, and everything is over y squared minus 3y, and this is divided by y plus 2. So now remember this y plus 2, everything is over 1. I need to, my aim is to change the what? Let's start with this one. Let's factorize this one. Ne? So if we factorize that top part, we can open two brackets like this, and this will be my y. I'm going to look for the factors of 6 that when I add or subtract them, they give us the middle term of that one. The factors of 6 is just 3 and 2, so this will be 3 and 2. Since 6 is negative, 1 should be positive, 1 should be negative. So this is how you choose. You're going to take the sign of the middle number, you give it to the bigger number. So we're going to take the sign of this negative, we give it the bigger number, and this will be positive. That's how you factorize, okay?
Okay.
Right. So now that we've managed to factorize the top, we can also factorize the bottom by taking out what? The common factor here, which will be y, and I'll be left with y minus 3. Now, I can change the multiplication, the division to multiplication. Remember, if we change, we're going to write the reciprocal of that guy. So our denominator becomes numerator, numerator becomes denominator. So this is what I have so far. Are you with me?
Yes, I am.
And this, let me show how easy this problem is. You just have to cancel the like terms. Look at this. Because this is a multiplication, this is just one term. So we can just write this as y minus 3 into y plus 2. Then we multiply this by 1 because we're going to take everything here, multiply by that 1. And we're going to take everything here, multiply by that y plus 2. So the top part, it will be like that, and the bottom part, this will be y into y minus 3 into y plus 2. So now the like terms, y plus 2 and y plus 2 cancels, y minus 3 cancels. So on top, we just have only 1 over y, because if we are cancelling something, whatever that we are cancelling, we'll only just have 1. So what I'm trying to say is that this is 1, 1, so the top part is 1 times 1 times 1, which is 1. Then this is 1, this is 1. Then y times 1 is just y. Then this is your final answer.
Okay.
Okay, let's move to the next question. Let's see what we have on the next one. Okay, so we have 3 to the power 2x plus 2. I think this is what we were doing last time on, what is this? On when did we do this? On our last session,
Yes, we are.
Yeah, on our last session, this is what we did. So I'll try to make sure to see if we can fit this problem here. So now remember, we talked about solving this. We said the most important thing is for us to change the base. Make sure that if this is 3, we can change that 9 and write it to base 3. So I think you still remember. So now the top part will be 3 to the power 2x, and this is added by, we're going to add 2, we minus. Remember the 9, we can change this as 3 squared, and this is to the power x. Everything is divided by, for now I'm just going to leave this as 3 to the power x times 3 to the power 2x plus 1. Okay, so to save time and space, we need to multiply out the brackets here. Look at this. We need to multiply the brackets, and this will just give us 3 to the power 2x. We multiply the exponents, and this will just be 3 to the power 2x. Are you happy with that?
Yes.
Right. And we said that we can reverse the loss of exponent and write this as 3 to the power 2x multiplied by 3 to the power 2, because when the base are the same, we're going to add the exponent. So we definitely reverse that. We still have minus 3 to the power 2x, everything divided by 3x times 3 to the power 2x times 3 to the power 1, because we also have to reverse the law. Look on top. I have a common factor of 3 to the power 2x. I can take out that common factor, but remember, where there's 3 to the power x, we're going to replace that by 1, because we are taking out 3 to the power 2x as a common factor. So I'll definitely do that. I'll take out that 3 to the power 2x on top as a common factor, and I'll have this as 3 to the power 2x. Then we set where there's 3 to the power 2x, we put 1. This will be 3 squared minus 1. That is the top part. So this is divided by, I'm just going to start with that 3 to the power 2x, because you are multiplying, the order doesn't matter. Ne?
Yes.
So look at the 3 to the power 2x. What happens to the 3 to the power 2x? They cancel, okay?
Yes.
So now, this guy and that guy cancel. We are left with, on top is 3 squared minus 1, it's 8. So it's 9 minus 1. The top part I'll have 8 over. The base are the same. We can add the exponents here. We can write that as 3 to the power x plus 1. Then this is simplified. Do you have any question based on that one?
No.
Okay. Determine the value of p if x minus 3 is a factor of 3x squared minus px minus 6. Tell me, do you understand what they mean when they say x minus 3 is a factor?
No.
You don't know what they mean when they say it's a factor? Look at this.
No.
Let's go back to this question. Y squared minus y minus 6. So we worked on this question on top. Né? So look at this. We factorized this and write it in that form. So this tells me that the y squared minus y minus 6, when we factorize it, it's y minus 3 into y plus 2. So when they say y minus 3, it's a factor of this. This is what they are referring for. So y minus 3, it's a factor of that equation. So if they say on this equation, on this problem, they say that x minus 3, it's a factor. So this tells me that I'm going to have x minus 3 as a factor. Then I need to find the second factor. So I'm just going to look for the second factor by inspection. So I'm going to look for the second factor by inspection. Look at this. I already have one factor. I know that to get 3x squared, I need to multiply this x by what? By 3x. Okay?
Yes.
And then we need to get minus 6. We already have minus 3. So since the 3 is negative, we need to multiply that minus 3 by positive 2. So now this is what we have. These are our factors. So please let me pause here so that I can check if you understand what we mean when I say by inspection. Do you understand how I got the other factors? Because the first bracket was given as the factor. This part here, it was given. So what I did is I just used inspection, because remember, when you do the FOIL method, this times this should give us the first part, and this times this should give us the last part.
Yes, okay, yes, I understand.
Okay, now let us multiply out the bracket. Let's see what we get. We're going to have x times 3x, which is 3x squared. Then we have x times 2, which is positive. This will be positive. It's x times 2 is positive 2x. Therefore, minus 3 times 3x, which will give us negative 9. So this will be minus 9x. Then this one will give us minus 6. So what I did, I just used inspection FOIL method to factor out the bracket. So look at this. This is 3x squared minus 7x minus 6, and this is equal to 0. So now, what is the value of p? Can you see that the value of p is minus 7? We can conclude and say, where there's p, the value of p is just negative 7. Do you understand how we got the value of p?
Yeah, no.
You don't understand?
No.
Okay, let me go back. Tell me which part you don't understand. Do you understand them? Do you understand how we got to this part?
Yes, I do understand.
Okay, nice. Now I need you to compare this equation with that equation. Can you see that it's one equation?
Yes.
It's 3x squared minus px minus 7x. So this tells you that this is p is minus 7.
So at the end of, like, for the 3x squared minus 7 minus 6 equals 0. So do you have to put the 0 there?
Oh, okay. Maybe if I put the 0, I'm just so this is not an equation, but since they said it's a factor, it's fine. You can also put a 0, because yeah, we can put a 0, but if you're not comfortable, let's remove the 0 now.
Okay.
Yeah. So now tell me, do you understand why we say p is minus 7?
Yes, you minus the 2 and the 9. It gave you negatives. Because it's like terms.
Nice. Nice. Let's work on this question too. Let's see what we can do now. Question C, determine the values of x. We are given x to the power 1 over 2 and they say this is equals to 5. So let me tell you now, the best way to do this, we need to isolate x now. So when you isolate x, we can multiply and say this guy, we multiply by the reciprocal of 1 over 2, which is just 2 over 1. And then what we do on the left hand side, we need to do on the right hand side. So let me write this properly now.
Yes.
We are given x to the power 1 over 2 and they say this is equals to 5. So what I'm saying is that to remove, because we are trying to solve for x, we just have to remove what? That 1 over 2. So we can multiply this by the reciprocal, which is 2 over 1, because if this is 2 over 1, this will just give us x, because the 2 and the 1 cancels. But what you do on the left hand side, you also do on the right hand side. So now x will be equals to 5 squared is 25. Then you are done solving the problem. So it doesn't matter what the exponent is. If I have k to the power 3 over 2 and they say this is equals to 4, to find k, you multiply this by 2 over 3. You also have to multiply the 4 to be 2 over 3. Then this one cancel, k will just be that 4 to the power 2 over 3. I'm not sure if you understand what we did here. Are you happy with that?
Yes, I am.
Okay, nice. So we're going to solve 2.2. 2.2.1. So I have 2.2.1 as 2x minus 9. This is equals to 3. So we need to isolate x. Let's take the 9 to the other side, which will be positive. This is 2x is equals to 3 plus 9 is 11, 12. Then I need to divide both sides by 2. Divide both sides by 2. The answer that you get is your x. Yes. You happy with that one, eh?
Yes.
Okay. So now look at this 2.2.2. This is 3 marks, né? So on 2.2. Look at this. This is just 3 marks. 2.2.2. So on this 2.2, if this is equated to 0, then you can say x is equals to 0 or x minus 6 is equal to 0. Then when you solve, x will be 6. But now it is not equated to 0. We can't use the 0 product property, but we need to multiply out the brackets. And then, so when we multiply out the bracket, this will be x times x, then x times minus 6. So this will give us x squared minus 6x. Then I need to take the 27, bring it this side to be negative 27, because we need to isolate everything to 0. Are you with me on that?
Yes.
So now can we factorize this? Can we factorize this problem? Yes, we can factorize the problem. So to factorize this, we're going to need the factors of 27 that when we add or subtract them, they give us a middle term of 6. So let's find the factors of 27. So it's 1 and 27. We know that 1 and 27 are the factors of 27. Another number that can divide 27 is 3. And we know that 27 divided by 3 is 9. Look at this. 9 and 3, they give us what? They give us 6 if we subtract them. If we say 9 minus 3, we get, if we say this is 9 minus what? I'm sorry. If we say 9 minus 3, we get an answer of 6. So now I'm going to open 2 brackets. I know that if this is x, the other side is x, and my factors, it's 9 and 3. So since 27 is negative, we need one bracket to be positive, one to be negative. So how do we choose which one is positive, and how do we choose that which one is negative? We take the sign of the middle number, we give it the bigger number. Then this will be positive. So when we solve this, now this is equal to 0. We can take the x minus 9, we can equate this to 0, or we can take the x plus 3 and equate this to 0. So x is just 9, or x is negative 3. Are you happy with that?
Yes.
Okay, let me give you a chance to solve 2.2.3. Let me see what you can get. This is just 2 marks. It should take you 2 minutes. Can you work on it? Tell me what you get.
Okay.
Are you still working on it?
Yes.
Okay, okay. This should be easy as I was taking you so long.
It's like I can do it with like small numbers, but like not a fraction.
Okay, like what is the aim here? Look at this 2.2.3. I have 2 to the x, which is equated to 1 over 8. When I have this, I'm going to check, can I write 8 to base 2? Yes. So this will be 2 to the x is equal to 1 over 2 to the power 3. So now that I have this, I need to remove the fraction. You remember the laws that we talked about, that if I have 1 over x to the power n, this can be written as x to the power negative n. So this will be same as saying 2 to the x is equals to 2 to the power negative 3. So we can use this law to change that fraction so that the base are the same. Look at this. The base are the same. We drop them. We're going to equate the exponent and say x is negative 3. Then this is fully solved. So now you were supposed to change that 8 to base 3, okay?
Okay, now I know.
You understand, eh?
Yes.
And remember, we did work on simultaneous last time. Tell me, did you guys do simultaneous at school?
No.
Not yet, ne?
Mm-mm.
So it won't be on your test, ne?
No.
Okay. I think that's it. This is what you should expect in your test. I think this is what you should expect in your test. But let's quickly, I'm just going to leave the last question because this type of question can change anytime, ne? Right.
Yes.
Can change anytime. So, okay, let me just quickly, let us open the next paper. Let's see what we have on that one. Asanda. Okay, this one is also the March common control test. Let's see what you have. You see, most of the things that we discussed on our lesson is it's what you're going to get on your question paper. We can just work this thing fast. So the first one, they want you to factorize. I think you already remember how we do the factorization. First thing first, we check if we have common factors and stuff like that. You still with me?
Yes.
Okay. Okay, let's first work on the first one. Let's factorize this. Let's see what we have. They want us to factorize. I'll check. Do I have a common factor? Look at this term. The first term, the x, yx squared. What is this? Not yx squared. It's xy squared. Then I have x on both sides, I have y on both sides. So my common factor will be xy. Therefore, what do we left with? We only have y, so the inside will be y, because when we multiply these two, we should get that xy squared. Then now plus 3x squared y. We have 1x out, 1y out. We are left with what? We are left with 3x. So this will be plus 3x. Then you are done factorizing. Ne?
Yes.
Right. So this one, remember how we factorize a quadratic? We open two brackets like this, and then we're going to have x on both sides. Then we look for the factors of 18 that when we add or subtract them, they give us 7. So we need to look for those factors of 18. So we know that factors of 18 is 1 and 8, 1 and 18. So when we add them, we don't get 7. When we subtract them, we don't get 7. We move to the next one. Can 2 divide 18? Yes. What is 2 divided by 18? We get 9. So look at this. 2 and 9 are the factors of 18. And when we say 9 minus 2, we get the middle term of 7. So I'm going to have 9 and 2. So since 18 is negative, 1 should be positive, 1 should be negative. Remember, how do we choose which one is negative, which one is positive?
Look at the middle term.
Exactly. We take the sign of the middle number, we give it the bigger number. So this other side will be positive. Then this is simply factorized. Even if they want you to solve for x, you just have to first find your factors, okay?
Yes.
Right.
Yes.
So on this 1.1.3, let's see what we can do from this one. What can we do? Remember, I said that try to group, ne? Try to group your something that, can you see that if I have 4y here and I have the y again on that term, I can group these two. I can write this as x squared y. I can say we add 4y, and then we're going to say what is this equals to. Okay, we're going to say when we add that, we'll have we'll be left with minus let's say minus 4x squared minus 16. So now what you need to ask yourself, why are we grouping? Because now the mistake that you can make is to group the 4x squared with the x squared, because you are looking at the x squared. Please don't do that. So if you do that, what will be the common factor on the other one? You see, we're going to have a problem, but it's best if you group it like this. Take out the common factor there, which is y. So I can take out, you see the first bracket, this is my first bracket, this will be my second bracket. So the first bracket, the common factor, it's y. I'll be left with x squared plus 4. Close the bracket. Now I have 4 can divide 16, so I need to take 4 out as a common factor. I'll be left with x squared plus 4, because if we multiply out the bracket with the negative, this will give us negative 16. So look at this. I still have the common factor again, which is x squared plus 4. Then inside the bracket, I'm left with y minus 4. Is this making sense? Are you happy with that?
Yes.
100%?
Yes.
Oh, okay. So simplify the expression fully. We need to simplify this. When they want you to simplify this type of question, you know what I need you to do? This will be 1.2.1. So this will be 1.2.1. So on this one, what I'm going to do, we need to take the 2x, multiply everything inside that bracket. Multiply everything, then you take the minus 1, you multiply everything in that bracket. So this will be 2x times x squared. This gives me 2x squared. Oh, x to the power 3, because the base are the same. and we are multiplying. So it's like saying 2x multiplied by x squared. So this is 2, the base are the same, we add the exponent because this is to the power 1. Then I need to take the 2x multiply with negative 3x, which will give me minus 6x squared. Then we multiply the 2x with 1, which will just only give us positive 2x. So now, minus x squared, it's minus 1 times x squared, which will give us minus x squared. Minus 1 times minus 3 gives us positive 3x, and then minus 1 times positive 1, just minus 1. We group the like terms. Look at these two guys. These are the like terms, and these are the like terms. We need to add them. I'll have this as 2x to the power 3 minus 6x squared minus x squared is just minus 7x squared. 2x plus 3x is just 5. Then I still have minus 1. Then this is it's simply this is simplified fully.
Yes.
Are you happy with that? Please, if
Yes,
you have
I am.
questions, you need to ask questions. And if I'm moving fast, please tell me. Nah?
Okay.
Nice. Okay, look at what we have on this 1.2.2. It has to do with fractions. So now, to solve this problem, you know what I'm going to do? I'm just going to start by saying, let's change this division into multiplication, and then let's factorize the top part. Right, so when we factorize the top part, remember I just showed you on the previous question paper. Let's go back. Remember we talked about, where is it? This part, you see? No, where is that example? Did we remove the example? Oh yes, you still remember how I showed you how to factorize the difference of squared? We said this will be
Yes.
y plus z, and the other side will be y minus z. Okay, so
Yeah.
look at this. We still have the same issue here. I said it's going to be, we have x squared minus 1. It's a minus number, so we can write it as squared because 1 squared is just 1. Then I can open my brackets, so it will be x minus 1. The other side will be x plus 1. So if we factorize this, I'm going to leave the top part as x minus 1 into x plus 1. Then this is over. I have a common factor here because I need to save time. Can you see that I have x plus 2, x plus 2? Let's take out that common factor, x plus 2. So if we take out the common factor, where there's x plus 2, we replace that with 1. So inside the bracket we'll have this as 1 plus x. Right, can you see that the 1 plus x, we can write this as x plus 1 because we are adding, the order doesn't matter. So I'm going to rearrange this so that it can be the same as that part. So I'm going to say this guy, instead of x plus x, I'll just write this as, instead of 1 plus x, I'll write it as x plus 1. Okay, I hope you are with me on that. So this will be x plus 1. Then now we said we'll change the division to multiplication, but the 2x plus 4 will come on top. But remember, the 2x, we can take out the 2 out as a common factor, and we'll be left with x plus 2. So this will come on top. This will be 2 into x plus 2, and on bottom we'll have the x minus 1. So remember, when we multiply, we can just look at the terms that are the same so that we can cancel the terms. So what I'm trying to say, we can say x minus 1 cancel. This will be left with 1. The x plus 2 cancel. This will be left with 1. x plus 1 cancel. So you look at what you have on top and what you have on bottom. Check if you have common terms that can cancel. So on top we just left with 2, on bottom with 1. So the answer is just 2. Is this making sense? Like, are you happy with this?
Yes, I am.
Okay, 100%. 100%. So I'm just going to leave the 1.2.3 for you to practice. Now remember what you need to do. Change the 4 into, this will be 2 to the power 2. Everything is multiplied by n minus 1. The 12. The 12 we can write it as what? The 12 is like 4 multiplied by 3. But the 4 you can write it as 2 to the power 2 times 3. So we're going to change the 12, write it in that form. Then when you are done, apply the laws of exponents, work on it step by step, okay? So I'm just going to leave the 1.2 as a practice there.
Yes.
Right, tell me, do you have any question based on what we've covered today?
No, I don't. But I'll text you if I do.
Okay, no problem. Let's just quickly work on this one fast. Let's, since we still have time, we still have 9 minutes. Let's quickly work on this one fast. Né? So look at this. The first one, they said you must solve for x. So remember, I said that if this is equated to 0, we can take the x, say this is 0, or we can take the 2x minus 5, let's equate this to 0. So now this is the zero product property. Therefore, what is 2x equals to? It's 5. The 5 will move to the other side. Divide both sides by 2. Therefore, what is x? X is just 5 over 2, or x is 0. Now, how do we factorize this if we have the value of a as 3, if it's not 1? This is how you factorize this 2.1.2. So to factorize the 2.1.2, look at this now. We're going to open two brackets like this, and then I'll say this is my 3x. We write the 3x first, then you put the x on the other side. Then you're going to look for the factors of 8. And if you still remember the factors of 8 that we can use, it's 4 and 2. So I'll show you how to choose this now. It's 4 and 2. Now look at this. We need to decide where are we going to put the 4 and where are we going to put the 2. You start with the bigger number now. You put it on this bracket. You see the bracket that has only x, you put 4. Look at this. What is 3 times 4? It gives us 12. Yes. So tell me, is 12 close to 2?
No.
No, that won't work. So the 4, if the 4 goes to that bracket, that won't work. Then we're going to put another one, which is to tell me what is 3 times 2 is 6. So can you see that we have 6x, and the other time we got 12x when we put 4. So this one is 4, we'll take the 6. So this tells us that the 2 will come this side, and then the 4 will come this side.
Okay.
Right. Now we need to decide on we need to decide on what? We need to decide on the signs. We need to decide on the sign. Remember that on our factors, this side, we don't say the sign of the middle number, we give it the bigger number. No, that's not what we do. What we're going to do, we need to know that what is 3x times 2? These two guys will give us 6x. So now if this is 6x and you are looking for minus 2, so this tells you that this 6x should be negative. So that if the 6x is negative, we can add the 4x to get what? Negative 2x. So we need to put this 4x negative so that we can subtract, we can say this is minus 6. Okay, this is minus 6, then we're going to add the 4x. I'm not sure if you understand the method that I used to factorize this.
Do you have a different method?
The ones that I have, they have to do with grade 11. It's the quadratic formula, but trust me, this is the best method that you can use. First thing, find the factors, then you test which bracket you're going to put the 4 and the 2. Then now on the sign, we know that if we say 3 times 2, we get 6x. But now if this is 6x, we need to say, okay, the 2 should be negative, so that if we have minus 6x, we can add 4x to get that negative 2. So the aim is to get the middle term of negative 2.
Okay.
Right. Do you want me to repeat this? Do you want us to do this again?
Yes, please.
Okay. Let's explain this problem again. Just give me a second now. Okay, remember we have the factors of 8, and we said the factors of 8 is what? The factors of 8 is 4 and 2. Then we said if we put 4 this side, we get 3 times 4 to be 12, and 12 is 4. Okay, we said 3 times 4 gives us 12x. But if we put the 2 this side, we get 6x. We need to choose the smallest one, which is this one. So the 2 will come this side. I'm going to write my 2 that side, and then this tells you the 4 comes this side. Right, now we need to decide, since this one is negative, one should be positive, and then one should be negative. So look at this. Let's say if I have plus 6x. So can you see that if this is positive, I have plus 6x, then this one is negative. I'll have to subtract 4x. I'll get the answer of 2x, and I need my answer to be negative. So I'm going to give this bigger number 6x negative. So how can I give the 6x negative? By letting that 2 to be negative. So now I need to let this 2 to be negative, so that I can get negative 6x, and then this should be positive, so that I can add 4x, and this will give me negative 2x. I hope if we do it like this, it makes sense. We are looking for this, so if the other side is positive, this won't work. Then now we can equate this to 0 and solve. So I'll have the 3x plus 4, this is equal to 0, or I'll have the x minus 2 to be 0. Now this side, I'll have 3x is equal to negative 4, and x will just be minus 4 over 3, or x is just 2. Are you happy with how we answered this question?
Yes.
Because before we enter the lesson, I want us to work on 2.1.3. So look at this 2.1.3. This has to do with exponential equations. I have 5 to the power 2x minus 1 is equal to 0. So whatever number that you have, try to move it this side, so that we can write this as 5 to the power 2x is equals to 1. Remember, any number to the power 0 is 1. So if I have 8 to the power 0, I get 1. So now what is this telling you is that this one, we can write it as same base as 5. We can write this as 2 to the power 5. It's equals to, or 5 to the power 2x is equal to 5 to the power 0. 5 to the power 0 is equals to 1. So we just change this so that the base are the same. We can drop the base and equate the exponent. I have 2x to be 1 to be 0. Divide both sides by 2. Divide both sides by 2. Therefore, what is your x? Your x is just 0. So meaning that if your x is 0, you can just go back to this equation where there's x, put 0, and you'll get your answer as 0 at the end. Né? That's how you can prove your answer. So this is where I'm going to stop. Tell me, do you understand what we did today?
Yes, I can understand everything.
Are you happy?
Yes, I am.
Okay, I'll see you on our next lesson. Né?
Okay.
Okay, thank you very much. Bye.
Thank you, guys.